Okay. The solubility of an organic compound is all about the balance between the hydrophilic and hydrophobic parts. So this is the hydrophobic part. It's the part that doesn't like water, the hydrocarbon chains. Okay, that's non-polar. And non-polar things are kind of pushed out in polar solutions like water. Water is a highly polar solvent, and it kind of tends to push out the things that are non-polar. Well, if we put an alcohol group on here, then this part over here, this is a highly polar part. In fact, this structure, this OH structure, is capable of doing hydrogen bonding. Hydrogen bonding is something that's even more than polar. It's somewhere between being a covalent bond and an actual, and just polar attractions. Okay? So this part is attracted to water. That's the hydrophilic part, water-loving part. And this is the hydrophobic part, water-hating part. Okay? And so if this side, if we get a chain that's longer and longer and longer, eventually this side takes over. It's kind of a tug of war. You know, and you think about it like that. This side's pulling into water, this side's pulling out. And as long as this side isn't too big, this is pretty soluble. So this is a pretty highly soluble alcohol here. On the other hand, if I get a really long chain, well, now the hydrophobic part takes over, and this is pretty much insoluble. It's only ever so slightly soluble, maybe. Okay? Well, what's in the packet about this is an extension from the previous unit, where we learned about some of this stuff too. Okay? So, as I said from the beginning of class, I know you weren't here at the beginning of my class, chemistry is highly cumulative. Every test is a review from the previous tests. Tests, plural. Everything we do in Unit 1 comes back again. Everything we do at Unit 2 comes back again. And so forth. It all builds up. Okay? Now, the alcohol group is the most polar of the functional groups we can put on one of these hydrocarbons. Okay, this is another polar group that's capable of hydrogen bonding, but it's not quite so powerful a hydrophilic functional group as this one is, but it still does the job. So as long as this chain here, this hydrocarbon chain, is fairly small, this part allows this to dissolve in water pretty easily. Okay? But if we make that chain longer and longer, eventually make it too long for it to do any good. It has to do with the polarity overall. Now, we're not talking about slightly polar. We're talking about something that's a completely polar end and a completely non-polar end. You know, if we get something like sugar, sugar is mostly these carbon chains. And if it were just carbons and hydrogens, it'd be pretty much non-polar and it wouldn't dissolve in water. But sugar has a bunch of OH groups on there. Now, I've really super simplified this structure here because sugar is more complex than this, but I've kind of made it simple here. Okay? But with all those OH groups on there, sugar dissolves in water in a hurry because that's a lot of polarity there, right? A lot of hydrogen bonding.